All right, welcome to lesson 12-1. Chapter 12 is all about data analysis. Data analysis is just different tools that we use in order to analyze and compare numbers, and it's basically we're using math in real life now, right? These are everyday uses of math that you've probably used before and that you're going to continue to use throughout your life. So our first lesson is on mean, median, and mode. So by the end of this lesson, you're going to be able to find the mean, the median, and the mode of a set of data, so of a set of numbers. And you're going to choose the best measure of central tendency. So these three, mean, median, and mode, are called measures of central tendency. So what's the tendency for this? There are ways of measuring. What's the tendency? What's the most common number? What's the most, what's the middle number? What's the average number? What's the tendency based on this set of data? So we're going to go through and I'm going to define each of these terms. So the first term we're going to look at, our set of data, we're going to consider is 2, 3, 4, 5, 8, and 12. So the mean, we're going to look at the mean for this set of data. Mean is the sum of data values. The sum of data values divided by the number of data values. Another name for the mean is average. So I'm going to go ahead and show you an example of mean with this set of data we were given. So average is another term for this. So for example, we would sum, so we're going to add up 2 plus 3 plus 4 plus 5 plus 8 plus 8 plus 12. We'll sum them, add them all up. Then we're going to divide the sum by the number of data values. So how many numbers are there? There's 1, 2, 3, 4, 5, 6, 7. There's 7 different numbers of data values. So we're going to add 2 plus 3 plus 4 plus 5 plus 8 plus 8 plus 12, and then divide by 7. So that equals 42 divided by 7, which equals 6. So our average, or our mean, is 6. All right, we're going to go ahead and use the same set of data in order to define the median. The median is the middle number when data values are written in order. So it's the middle number in a set of data when we list the data values in order from like least to greatest. So I've already written my data values in order, starting with 2 and going up to 12. It's the middle number when you have an odd set of data values. If you have an even, if you have an even number of data values, you can't really find the middle between 6. That would be 3 numbers on each side. So if there's an even number of data values, then you take the 2 middle numbers. So if you have an odd number of data values, your middle number is the median. So like in our set, we have 2, 8, 3, 8, 4, 8. Number 5 is our median because it's in the middle, right? There's 3 numbers on both sides. 5 is in the middle because we have an odd number of values. If we had an even number of values, we would pick the 2 middle values to represent the median. All right, our third measure of central tendency is the mode. We're going to use, again, the same set of numbers to show what this is. The mode is the data item that is written the most often. The one that happens or occurs most often. So if each number is written only one time, then there really is no mode. If there's one number that's written the most, there can be one mode. So there can be one mode. You can have more than one mode if you have 2 numbers that are written twice and all the rest of the numbers are written once. Or no mode. So in this example, the mode, data item that occurs the most often, 8 occurs 2 times, so the mode equals 8 in this case. Because 8 is the only number that occurs 2 times in this set. One more type of way of talking about numbers is you can describe the range. And the range is the set, is a set of data, is the difference between the greatest and least values. So what's the range? What's the difference between the greatest and least values? So for example, in that other set, we have 2, 3, 4, 5, 8, 8, and 12. Well, your least is 2, your greatest is 12, right? You look at the greatest and least. You want to find the difference. So we're going to do 12 minus 2. 12 minus 2 equals 10. So your range equals 10. All right. I'm going to go ahead Alright, so we're going to do an example with finding the mean, median, mode, and range for a given data set. So this is example 1. I have a graph drawn with several students' names. They're Raya, Lily, Sophie, Carrie, Kelly, and Faith. And this data set is showing the readathon. Number of pages read. So looking at this graph, you can see Raya read 40 pages, Lily 45, Sophie 48, Carrie and Kelly each read 50 pages, and Faith read 59 pages. So we're going to find the average number of pages read. So we're going to find the mean. The mean of this data set, we're going to add up our total number, the sum of the data values. So sum our data divided by the number of data values. So we're going to add 40 plus 50 plus 45 plus 48 plus another 50 plus 59. All divided by, we have 1, 2, 3, 4, 5, 6. 6 girls that read. So that equals, if you add up all those numbers, 292 divided by 6, which equals 48 point, about 6 repeating, which is approximately, if we round to the nearest tenth, 48.7 pages each. So each student read approximately 48.7 pages. That's our mean. We're going to go ahead and we're going to find the mode. Let's go ahead and do the median first. The median, remember, is the middle number of data set. Well, my data is already going from 40, 45, 48, 50, 50, 59. It's already going in number order. So I'm going to find the median. My data is written in order. So my two middle numbers are the 48 and 50. So 48 and 50. I'm going to find the average of these two numbers to get one median number. The median number, so I'm going to add up the averages of these two numbers. 48 plus 50 equals 98 divided by 2 equals 49 as my median, or the average of the two medians. I'm going to go ahead now and find the mode. The mode, remember, is the data value that occurs the most often. Well, out of all these data values, only 50 occurs twice. So 50 is my mode, because it occurs 2 times. Lastly, I'm going to find the range. The range is the difference between the greatest and least values. So I look at my greatest value is 59, my least value is 40. So I do 59 minus 40. 59 minus 40 is 19. So my range is 19. So now we've found, we can describe this data set in terms of its average number of pages read, the median, or like the middle number of pages read, the mode, the most common number of pages read. Most students read about 50 pages, or the range. The difference between greatest and least number of pages was only 19 pages. All right, I'm going to have you now complete an example on your own. So I'm going to give you a data set, and you're going to go ahead and find the mean, median, mode of this data set. I'll have you find the range as well. So your data set is 2.3, 4.3, 3.2, 2.9, 2.7, 2.3. Go ahead and pause the video. Once you've solved for the mean, median, mode, and range, press play to find out the answers. Alright, you should have started by renumbering the entire data set, right? Reordering it. So I'm going to go ahead and rewrite the data set in number order. 2.3, 2.3, 2.7, 2.9, 3.2, 4.2, 4.3. So now I have them in order from least to greatest. Their median, you're going to sum all those numbers and then divide by the number of numbers. Alright, so check your answers against the ones on the screen. Pause if you need to, and feel free to ask your teacher a question. Otherwise, I'm going to move on to another example. All right, so our next example we're going to practice with, doing mean, median, and mode, is to identify modes. So I'm going to give you a list of values, and I want you to identify the mode. So our first list, we're going to look at some different values of money. So $1.50, $2, $2.25, $2.40, $3.50, and $4. So now the question is there a mode, and what is it? So when you're looking to find the mode, you want to find what number repeats the most. Well, in this list, all of these numbers are only listed one time, so none of the numbers repeat. So since no numbers repeat, there is no mode. No values repeat, so there is no mode. Okay, we're going to look at another list of values. 2, 3, 6, 8, 8, 10, 11, 12, 14, 14, 18, and 20. Okay, now out of this list, we have 8 and 8 repeat, and 14 and 14. So we have two different numbers that repeat, and they repeat the same number of times. They both repeat twice. So we have two modes on this list. We have two repeating numbers that repeat the same number of times. So they're both 8 and 14 occur the most often in this list. Okay, we're going to do one more example. A list of words. Grape, grape, strawberry, strawberry, orange, strawberry, watermelon. Alright, so out of this list, grape and grape repeat more than once, but strawberry, 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 we have 3 strawberries. Therefore, we have only one mode, and that is strawberry, because strawberry is the word that occurs the most often out of this entire list. So it's important to note that sometimes you're going to have no mode if no numbers repeat or occur the most often. Sometimes you might have more than one if some numbers repeat the same number of times, like with 8 and 14. And sometimes you're going to have just one mode, one number that repeats the most often. And sometimes your numbers aren't going to be or what you're identifying the mode of might be words, not numbers. You just want to find, for the mode, what's the most common number, word, object, whatever it is you're examining. It's a way to categorize or identify things. Alright, so for your example that you're going to do on your own, figure out and identify how many modes are there in each of these lists, list A and B. Go ahead and pause the video, figure out how many modes there are, and then hit play when you're ready to check. Alright, you should have found that for A there is 3 modes, because 7 and 7 repeat 2 times, 8 and 8 repeat 2 times, 11 and 11 repeat 2 times. So 7, 8, and 11 are your most common numbers in this list. So there are 3 different modes. Out of the second list, 38.5 occurs 2 times. All your other numbers only occur once, so there's only one mode. All right, we're going to identify now outliers. So an outlier is a data number that's really great or really small in comparison to the other data values. So it just doesn't fit in with the crowd. So it's not going to be a number that's close to the other numbers. It's going to be like way off the other numbers. So if most of your numbers are like 7, 8, 9, the outlier would be like 1, because it's way different than 7, 8, and 9. It's much greater or much less. And the problem with outliers is that they can really affect or throw off the average or the mean of the data. For example, we'll do example 3. If you have, we'll do the 7, 8, 9. So I have 7, 8, 9, 10, and then I have the number 1 also. So if I wanted to find the average of this set of data, I'm going to add them up and divide by the number of numbers. 1, 2, 3, 4, 5. Okay, so that's going to equal 35 divided by 5. Now in this case, the number 1 doesn't really throw off your data a whole lot because, well, let's see. So 35 divided by 5 equals just 6. Oh, sorry, not 6, 7. 35 divided by 5 is 7. Now if we were to do this again and test it without the 1, if we added 7 plus 8 plus 9 plus 10, 15 plus 19 is 34 over 5. The number 1 doesn't throw it off too heavily. So that's about 6.8. So that's pretty close. But if you were talking, if I added the number 20 instead, that would throw off our data a lot. Instead of the average being 7, if you added in 20 to the list, 20 is a great outlier. It's not anywhere near 7, 8, 9, or 10. For example, 7 plus 8 plus 9 plus 10 plus 20 divided by 5. Let's see how that affects our average. So it's 54 over 5. That's about 10.8. So now our average on our list without any outliers here is 6.8. When we have an outlier that's way greater, we get an average of 10.8, which is even larger than our largest number on our regular list without an outlier, so it really throws off the average. So we're going to go ahead now and look at why outliers matter. Actually, first I'm going to have you identify some outliers. So we'll have you do sample 3A. I'm just going to give you a list of numbers, and I want you to identify which piece of data is the outlier. So I'm going to give you a list: 5,200, 6,500, 4,500, 2,500, 1,200, and 2,100. right, so go ahead, write down what you think is the outlier in this data set. All right, you should have identified, if you look at this list, 5,000, most of them are in the thousands, right? But 200 is way lower than most of these numbers. Your other number that could potentially be seen as an outlier is 6,500. 6,500 is much larger than like 1,200, 2,100, 2,500. So let's kind of see which one is the bigger outlier. We'll test it and find out by doing the average. So how does the outlier affect the mean or affect the average? So let's first find the average with the outlier, and then we'll find it without the outlier. So we'll add up all our numbers. Divide by the total number of numbers. Divide by 7. That equals that's 21,700 divided by 7, which equals 3,100. That's with the outlier. That's including both of what we could potentially see as outliers. Let's go ahead and try without the outlier. Let's try without 6,500 and see what the difference is. So 5,000 plus 200 plus 4,500, skip 6,500, plus 2,500 plus 12. Oops. Plus 21. Now we're going to be dividing by 6 because it's one less number. Equals that's 15,200 divided by 6, which equals about 2,500. So now the difference between our means here, we had 3,100 and 2,500 without the outlier. The difference is about 600, so that raises the average by about 600. That's a really big difference. If we tried with 200, it would lower our mean by a lot, as opposed to raising it. So just be aware of, when you're doing averages of numbers, it's good to be aware of, like, is there an outlier? Is there a number that's throwing off this data set that doesn't actually represent the average, because it's not anywhere near most numbers that we're dividing. I'm going to have you now we're going to identify or choose the best measure. Because sometimes all these different measures of central tendency, we have the mean, median, and mode. Sometimes there's what we call the best measure. Which measure of central tendency, so which the mean, median, or mode is the best to use in that particular case. Because there's different times we'd want to use different these different tools in order for different purposes. So we're going to try to determine, how do we know which measure is the best? All right, so I'm giving you, there's a list of the employees' hourly wages. So these are the rates that people earn each hour. So there's $5.5 an hour, $6 an hour, $6.50, $6.30, $8, or $17. So let's look at the different measures of central tendency for each one. So the mode in this set of data is 550 because the number 550 occurs the most often. It occurs 3 different times. No other number repeats. The mean or the average, if we add all these up, is, and then divide by 8, so there's 8 different numbers, is 750. And then the median, the number that is in the middle, if we list them in number order, is 610. So those are our measures of different measures of central tendency. The question is, what does these numbers tell us about the employee's hourly wages? So the mode is the lowest wage listed. So the mode doesn't really describe the actual central tendency because it's the lowest out of our set of data, right? The mean, 750, is well above the hourly wage of all but 2 workers, right? There's 2 workers that get 8 and 17, so they get above 750, but most of the other ones are working below that amount. Most of them are not getting paid 750. So it's kind of too high. It's influenced by that outlier 17. But the median, we would say the median is the best measure because it actually shows the central tendency. It's not influenced by the size of the outlier. It's not, in this case, it's not the lowest number and it's not the highest number. It's kind of right there, really in the middle. We have several people getting 550. We have a few that are getting higher. So the median is really showing us the central tendency in this particular case. So in order to determine what the best measure of central tendency is, you have to identify the mean, median, and mode, and kind of compare and think what would actually show me the best measure in this particular case. So we're going to do a few examples with this. What example 4? So we're going to identify the best measure. Okay, so if we want to identify the best measure of, first, the favorite movie of students in the 8th grade, let's think about what would best measure the central tendency. Well, favorite movies, it's not numerical. So you're not going to be using an average, right? You're not going to be able to find an average really easily. But if you're just quickly glancing at a list of favorite movies, you can really easily pick out which one occurs the most often. So the best measure of central tendency in this case would be the mode. So when data is not numerical, you might want to make a note to yourself. When data is not numerical, look at the mode. Use the mode if the data is not numerical. All right, we're going to look at another one. If we have daily high temperatures for a week in July, In order to find, to compare or look at or figure out the best central tendency of what's the daily high, right? What is the daily high that best represents all of the daily highs? Well, you're looking at a bunch of different numbers. There's not going to be an outlier likely, because in July you're going to have mostly the same temperatures. So you don't need to be too worried about like an average. And so you're going to have pretty similar numbers in terms of temperature. Probably 80s to 90s, right, for a week in July in California. And so you're going to be comparing those different numbers to one another. So the mean or the average is what you should use there. So when there's no outlier, use the mode. Or sorry, not use the mode, use the mean. Find the average. If you don't have a big number that's going to throw off your set and you have a list of numbers, just find the average. It's the best measure of central tendency. Okay, our third example, if we want to look at the distance, the different distances that students in our class travel to school. We would look at there, in this case, the median, because some students might live really, really far away from school and just get up really early and travel really far to school, but most students probably live closer to the school. But in that case, if you have a student or two that lives much farther away, they're going to throw off an average, so you wouldn't want to take the mean. And if you're wanting to find you have numbers, right? So we don't necessarily just need to glance at the mode. It would be more accurate to look at the median. What's the middle number that students are driving from school? So when you have a number that's way different than other numbers, so when you have an outlier, use the median. So the outlier is going to affect the mean, but it won't affect the median. Okay, now that you've got some tips, so if you have no numbers but just words, it's not numerical, look at the mode. If you have no outliers, use the mean. If you do have an outlier that's going to affect your results, that might significantly affect the mean, use the median. So I'm going to have you do one example by yourself. Alright, so your job is to look at these lists of the price of sports shirts, find the mean, median, and mode of this list, and then determine which is the best measure and explain why is that the best measure. Once you've done part A and B, hit play on the video. Alright, you should have found that the mean was 202 divided by 8 when you add up all those numbers, which is about $25.25. The median, if you line up your numbers in order and trace back to the two middle numbers, are 21 and 26. You're going to add those and divide by 2 and get 23.5 as your median. So find the average of the two middle numbers to get the median. And then the mode, the number that occurs most often, is 20. It occurs 2 times. All the other numbers do not repeat. Okay, now which price was the best measure? The best measure on this list could be probably said to be either the median or the mean. The mean represents the average. There is an outlier. 42 is an outlier. So the median, 23.5, is a better way to look at the average, because there's no outlier that throws off the data. And our mode is the lowest number that's repeating, so that doesn't really give us a sense of what's the average or central tendency for the price of a sports shirt. Okay, so your job now is to do some in-class practice. I'm going to have you do numbers 16 through 18. Whoops. 16 through 18. And then numbers 20 to 21. And then for your homework tonight is practice book page or lesson 12-1. So go ahead and get started on your in-class work now. Make sure you show your work and include all your calculations on your paper, what you've been typing into your calculator.